Hello, welcome to the Badger Podcast. This is Wasbi Boat Research. I'm here with none other than my main Badgers, Alex the Entrepreneur, and Hal, aka 1500 Badger LLC. What's going on, guys?
Glad to be here.
How's it going?
So today we are continuing with a series that I'm calling DeFi Beyond the Basics. And we started this with two videos with Alex and I where we kind of went really deep on security in DeFi. So if you haven't checked those out, please do, because it has a lot of information about how to avoid rugs and hacks and stuff like that. But now we're going to kind of get on to other topics that users may, if you're a casual DeFi user, you might be used to them, but there are kind of universes that open up when you go beyond the surface. So if you're looking to get more serious about DeFi and save money or optimize or do the multiple transactions per day, these are things that are going to really help you to get to that next level. So today we are talking about everyone's favorite complaint, gas fees. The gas is too damn high, and we're just going to go through a bunch of things that maybe you didn't know about gas. If you're someone like me and think gas is just kind of like one number that goes up and down like the weather, we're going to get a little bit deeper and into some ways where you can save a ton of ETH on gas and not get wrecked. So I'm excited about this.
Gas.
All right, it's a gas. All right, so let's go up into this. So I'll play the naive DeFi user, which is very close to reality here. So my understanding of gas is it's a number that goes up and down. It makes transactions more or less expensive if it's higher gas, and that's really all I know about it, right? If it's too high, I'm either just going to kind of like FOMO my transaction and do it and say screw it and then regret it later, or just wait or put off my transaction till it goes down. So I don't know what am I missing here? What are the things about gas, Alex, that I'm kind of naively going about this?
Yeah, and the discussion about gas gets really deep. So it's like an onion. Let's try and peel it one layer at a time. But fundamentally, when we talk about gas, we're talking about two different things. You have the gas cost, and then you have the amount of gas that is used by a transaction. So gas can be considered as a unit, as in this transaction cost me 2,000 or 2,100 gas or 21,000 gas, versus gas as the gas cost, which is what you typically change either via the slider or via the up and the down arrows on MetaMask. The gas units are coded and calculated by the Ethereum nodes to determine how complex an operation is. And as such, they try and bill it, just literally like you will pay for the highway. Based on how long the highway is and how many services it offers, you pay a different fee. So that's how you can look at it. The more amenities in an hotel, the more you pay for it. The more stuff your transaction does, the more you got to pay for it. And then the other component, which is the gas cost, is effectively a multiplier that is used to determine what the actual transaction cost will be. And the gas cost is almost you can view it literally as a socio-economical experiment, because ultimately the more people want their transaction to be mined now, the more the gas rises. It's literally a pure demand and offer Nash equilibrium between what people are willing to pay and how long people are willing to wait in order to utilize Ethereum. So ultimately, again, there's these 2 points: gas cost and the gas as a unit. Does that make sense?
It does. So what I think might be a helpful way to do this is I'm just going to Uniswap and going to say like I'm making a trade, and a confirmation comes up in my MetaMask, right? And it's showing me a bunch of different numbers. It's showing me the estimated gas fee. It's showing me the max fee. And then if I click into edit, it's showing me the gas limit, max priority fee, and max fee. So maybe we could just go through each one of these and do a quick explainer of what each one is and how they all come together in one transaction?
Sounds great. Before we get to that, I want to just add a second layer to the Gassss discussion, and it's that ultimately we like, what is a blockchain? What is Ethereum? Ethereum is a Byzantine fault tolerant system, which means that it's a lot closer to BitTorrent in the sense that you are trying to share information between different peers. There is no leader; it's headless. And so, in order to coordinate that, you have to structure incentives that basically avoid people just destroying the system. And so, if you wanted to destroy a website, what you will do is you will do a DDoS attack. And a DDoS attack means that you just send a bunch of requests from either a click farm or a zombie farm, which is basically a bunch of computers you hacked, so that those computers can perform requests on a server and overload it. And that's basically the goal of a DDoS. In a decentralized network, you will do the same thing by doing cheap transaction with nothing or transaction with zero values, with the pure goal of just making every node in the chain explode. That's something that is happening on sidechains. If you go on newer sidechains, I'm not going to mention the names, but you can find a lot of chains that get shut down for days, for hours. And the joke is AWS is down tonight. But the reality is that they are under insane levels of attacks because of how complex the systems are and how economically viable it can be to exploit them. And so ultimately, the gas cost is a way to preserve the blockchain itself, to save against abuse, if that makes sense.
That's kind of what's happened with all the 10,000 NFT projects, right? It's like blowing up the gas costs on Ethereum. And then I think what you're saying is that at some point you got to pay the price, right? Like if all of those things aren't economical, then they should theoretically go away, and the gas should come back down, unless they really are worth the compute power that they're taking up.
Yeah, I mean, if we take the Michael Saylor idea of Bitcoin being Manhattan, being a square in Manhattan, and you want to own that, we can use the same metaphor to say that a block on Ethereum is basically an event in a nightclub, and that event is going to last only a certain amount of time. So if you really want to go there, let's say it's a really cool club, in the, what is it, the meatpacking
Yeah.
meatpacking neighborhood in New York, you're gonna pay for it. Sometimes you're willing to pay for it, and that's literally what happens with people paying thousands of dollars in Ethereum in order to do their mint or in order to do their swap right now, to do it as fast as possible, because it actually becomes that valuable.
This also where miner extracted value comes from, right? Where people are essentially front running your transaction because they're willing. They see an opportunity. They're willing to pay more gas than you to get their transaction in front of you. Do I have that right?
That's a very interesting point. I think through MEV, which has been rebranded to maximum extractable value, no longer miner, because there's different agents. But ultimately, through MEV, you could argue that MEV is the only metric that will allow you to fairly price gas. Because ultimately, if a system, let's say Ethereum as a whole, or you as a smaller subset, you can look at Uniswap and all the trades you can make on Uniswap, or Curve and all the trades you can make there. If there's enough value to be had there, let's say there's $1,000 in arbitrage on this block right now, then the simple question that you would ask yourself is how much am I willing to pay for what is effectively a risk-free trade? Because that's what the arbitrage is. Obviously, you can be front run and you can lose that trade, but that's why tools such as Flashbot, which effectively make it so you don't have to pay for transaction reverts, ends up helping at that level. So, just to give you a hint, the value of a chain, or like if you look at Gestalt theory, which is something from psychology, they say the total value of a system is greater than the sum of its parts. So if you look at it that way, then the value of Ethereum is bigger than the gas cost that people are willing to pay, and people are willing to pay a lot of money to use Ethereum because of these opportunities and because of the perceived value and the realized value over time.
Yep. So we know, okay, so gas, think someone on Twitter had a comment the other day that was like, whenever you see gas high, that means someone's getting rich, right? Because like they're willing to pay this fee because there's some extractable value or some benefit that they're getting out of this transaction, right? Or some NFT that they really value or whatever, right? So it's just kind of a direct function of the value of the network, and higher value network, it's going to cost more to transact on it because that they need to increase the congestion charge so that these spam transactions don't overload the network.
Yeah, exactly. Ultimately, you want to build a solid system. And to build a solid system, it has to be a little slow because everybody has to check everybody else. And at the same time, you need to find incentives that fight against it. Bitcoin used difficulty. I believe difficulty is also part of the algorithm used in Ethereum. But then, since Ethereum also is a generalized computer, a Turing complete machine, you need to prevent these denial of service operations by charging a fee for the privilege of using the system.
All right. So I think we've kind of covered what is gas and why is it important, and why it doesn't, why it makes sense to pay it in order to use a valuable network, right? So should we now go into the kind of gas components of an individual transaction, like when a MetaMask, because like like you go on these sites like Gas Now or Etherscan, and it's telling you what the gas is right at this moment. But then a lot of times when you go into MetaMask, you're presented with all these different numbers, and it's kind of a bit different than what you're seeing in these other places. So like, I don't know, there are things that make sense if you're a developer that you really need to get in the weeds, but what is kind of like the minimal understanding of gas, these numbers that come up in MetaMask that someone needs to kind of transact efficiently when they're doing a swap or a basic transaction?
Yeah. So anytime you're going to run a transaction on Ethereum, as we've established, you're going to have to determine how much gas you're willing to pay. And so most of the times, tools such as MetaMask will try and come up with their best effort solution. However, as you also mentioned, there are multiple tools that allow you to predict that. And I'm going to share the ones that I use. I use ETH Gas Station. It used to be the best. Then Gas Now came, but Gas Now is dead now. There's ETH Gas Watch, which is a fork of it, but it's not as good. I believe there's another one called Blockworks, which is as good as Gas Now, but it's just a little more complicated. And lastly, the last tool you could use is on Etherscan by just going on /gas tracker. You're going to see some estimated cost for your transaction, such as the cost of a transfer, the cost of a trade, etc., as well as the current gas cost with some extra details, as you mentioned. So if you look at the older resources, you'll see that the only thing we mention is gas cost, right? There's sometimes gas limit, which for the purposes of our conversation, gas limit is just again the amount of gas you're going to spend when you think about gas as a unit, versus the gas cost, which is the price that you're willing to pay for that gas, and that gas cost is calculated in GUE, which is a sub unit of Ethereum, where Ether being the unit with 18 decimals. GUE is 8 decimals. Let me make sure I got that right. I believe GUE is in 8 decimals. So if you look at what is it, 100 million? Let me make sure. If you look at a billion GUE, so it's a 10 to the minus 9 Ether. So if you look at a billion GUE, that's one ETH. So if you're going to spend 1 billion GUE in one transaction, you're going to spend one ETH. But ultimately, GUE is the unit that is used to calculate for gas cost. And that used to be it. And then now we have a EIP 1559, which introduced a lot of changes. And so ultimately, we restructured the way you run a transaction. So going back to the MetaMask example, let's say I go on Uniswap and I run a trade. I'm going to go on MetaMask. The first thing I'll see is just a total price, right? That's what the first thing you see. And that's, again, MetaMask trying to tell you what your maximum cost is going to be. Again, MetaMask doesn't know what the transaction will actually end up costing, as in how much gas units is actually going to use. So it's trying to give you a best effort estimation of the fee that you're going to pay. Again, estimated gas fee. And then you're going to see a total, which is just the amount plus the gas fee. Then, if you go in the edit settings, you'll see some bigger levels of breakdowns. And typically, this used to be a little more intuitive, but typically, based on your uses, you're going to have the option to go for a faster transaction or a slower transaction. And but most people just always use the fastest one because, again, Ethereum is kind of worth it. But again, going in the settings, you'll see the gas limit. You never want to change that because the gas limit is the units you're gonna allow to use for this transaction. It's basically the prepaid amount.
And that is basically like as a function of the smart. That's in the smart contract. It's saying that this smart contract has a certain amount of data that it's processing, and that gas limit is how much data is needed to be written to Ethereum or used. How much like processing power the transaction needs, right? So is that a good way to think of it?
Yeah, intuitively, that's what it is. It's basically a pre-calculated amount. Practically, there is the Ethereum node, which is typically built in Go, so it's called Geth. But ultimately, you're going to make a request to that node by telling them, "I want to do the swap with these inputs," and then it's going to do what is called a if call, which is an operation that runs some math internally, figures out all the operations, and from those operations, it tells you how much gas you would use to run the actual transaction. And that gas is then used by your client, the MetaMask, as the gas limit, because now you know how much gas you're going to need. And so there's no point in you, in a way, prepaying or pre-authorizing spending more than that gas.
So when you go to make a swap, it's actually communicating with the Ethereum node, and that number, the gas limit, has come back to your computer from the Ethereum node and saying, okay, this transaction is going to require this much processing power.
Exactly. That's typically the optimistic estimation. So Ethereum doesn't, the node doesn't know what's going to happen in the future. It can only calculate what has happened until now. And so when we go in the topic of being front run or trades, the slippage and stuff like that, the node doesn't know about that stuff. But what the node can give you as a guarantee is that when it estimated the cost, it went through that exact amount of gas, and that's the gas that it's telling you to use as its gas limit for the transaction.
So I'm curious why it allows you to set it higher or lower. Why would anyone want to tinker with that amount if that's basically like if you really had a high priority transaction, you would put it up for some reason, or I'm not sure why you would want to change it.
Yeah. Let's. I think it's an amazing question. Let's go through a simple example of how Ethereum will work in a world where MetaMask doesn't exist. Okay. So if MetaMask didn't exist, basically you would have to do the operation we showed in the video with me and Wasbi, where we go through the paper ending 1ENS and looking for the approvals. You basically will need to figure out all the hexadecimal data to set up in your data field. And then you would have to figure out this gas limit. And you will probably just put a random number. Let's say you will put 1 million gas, which is, in this case, I get 206,000 gas. So it's 5 times too much. But why is that a viable strategy? The reason why is because once the transaction is actually mined, the transaction can't use more gas than what it actually uses. The miner can't steal that gas. It can't, create a new set of paths in the code to make it so that it wastes gas so that they get more out of it. They get no advantage in doing that because they can't. And so the gas limit is kind of this legacy idea of I'm gonna make a limit to the amount I'm gonna spend, just like doing a prepaid card for one transaction. I'm gonna create one card that pays this gas for one time, and I'm gonna authorize that. But ultimately, the reality is that it's there more as a low-level system to avoid you overpaying, more so than for you, in a way, paying the right amount, because you don't know how much gas you're gonna pay up until the transaction is actually mined. So there can be slight fluctuations between the limit and the actual price and the actual gas used. And in a way, it's there just for your own protection as the developer. So it's a really odd tool for the end user.
Yeah, and The analogy I see it is like if you're going to go travel somewhere on some trains or something, okay, you need to take at least $50 with you because along the way they're going to charge you somewhere between 20 and 30, and if you don't pay it, they're going to kick you off, right?
That's exactly what happens. And funny enough, if you don't pay enough gas, your transaction will run out of gas, which doesn't mean that you get reimbursed. You don't go back to the first station. You actually end up getting the transaction reverted. So your money goes back to the previous station, but you actually still pay for the gas you've used. So it actually is the worst case scenario when you set the gas limit to something too low. You don't get what you want and you still pay for it.
Yeah, that's pretty rough. And I feel like the one thing I noticed just as a user between EIP 1559 and prior to it is a lot less of my transactions failed, even though I was paying more.
That's a great insight. Ultimately, the reason why EIP 159 was born was to provide a better user experience for users. So if you if you experience the original gas price wars on Ethereum and how the gas worked, ultimately the way it worked was you would go on something like a estimation tool such as Gas Station, and you will see a number, let's say 200 Gwei, and then you just look at your own pockets and you think about it and you think how worth your transaction is. And if you are anywhere close to operating in thousands of dollars, the normal operation would be to just set the gas to 300, which is 1.3 times more than the normal, and you would just pay for it because it's not worth the hassle of waiting and having a queue of transaction and stuff like that. So the user experience was awful for two reasons. One, you wouldn't know predictably when your transaction was mined. That's one issue. You don't know how much you have to wait. And the second issue was that you would always overpay in order to guarantee a fast mine, right? There is no exact formula for getting mined fast. And so people would just always overpay ridiculous amounts. And that's probably what you guys used to do. Anytime you had some urgency, you just put an insane number, not because you thought about it, just because it feels like there's no way it's going to get that expensive, right?
Yeah, and if you don't do that, then the transaction fails twice and you end up paying more gas anyways.
Exactly. You literally are in limbo. And then most people will regret and they perhaps try to cancel the transaction. And so for people that are advanced, there was a clear problem of paying too much and not having predictability. And for people that were new, let's say you get your dad $10 of Ethereum, and then they press a button, and for some reason the gas price is zero because it was still loading, or maybe the gas price is 10, but the real gas price now is maybe 100, and they see this transaction stuck there for a week, and they have literally no idea what's going on. They don't have the tools to cancel it. The canceling tool sometimes works, sometimes it doesn't. And so ultimately, it was just a terrible user experience for everybody at both levels, at the newbie level and at the advanced level. And so the goal of EIP 1559 was to structure the gas price based on demand. That was the real initial goal of it. And the idea was that you would structure the prices by looking at usage. So each block for the same idea of avoiding a denial of service, each block is capped by a certain amount of gas. I believe the current gas limit is 15 million. I remember it being 12 million. I remember it being 10 and maybe even 8 million back a few years ago. So the gas limit is a number, though, that tells you how much gas can be used on a block. And again, if gas is literally how many train stops you can go through or how many operation can be done, you can imagine that based on the gas limit, you're going to have a limit on the amount of transactions that can happen on each block, right? So if you use that analogy, then how do you figure out how to price it properly? The way they did it in EIP 1559 is that anytime you go above a certain threshold, and I believe it's 70% of usage, let's say above 50, but again, it's above a certain threshold, what the miner does is they start to raise the price of gas for everybody, and they do it in a predictable way. So the each block, instead of having a fixed amount of gas that it can have as a limit, they actually make it so that it can be up to double. I believe from 15 million up to, it used to be up to 20 million, but now I believe it's up to 30 million gas. But what they do is that if you're using the gas above the 15 million, above the normal threshold, then the next block will automatically cost more for everybody. And they sequentially do that over a period of time, so that instead of having one block costing 10 Gwei and another block costing 100 Gwei in a subsequent block, they try to smoothen that out through like a Gaussian curve, one of those curve for the mean, right? With 50% being in the center, so that if prices are skyrocketing, they are still going to skyrocket, but they're going to do that over time in a predictable way. Does that make sense?
Yeah. Well, and I just want to explain for a second how this screwed over the little guy, because even though it was annoying the way that the gas was working, where you could have failed transactions and you had to put in higher prices and stuff like that. I was trading, or I've been trading in DeFi for, essentially since just after DeFi summer. And what I used to be able to do was, whenever you had high moments of volatility when prices were moving or something, right? If you miss selling before the price goes down, there's no point in selling after the price goes down. So what you could do is you could just wait for gas to calm down, or you could wait till like 2 a.m. or something, and then rebalance your portfolio. Or now what happens, like that phenomenon you're talking about, where when gas goes up, it brings sort of that average base fee up, so that has like a stickiness to it, and so then you have to wait for even longer until you can get to a point where the gas comes down to rebalance, right? If you didn't get out of the trade early enough. So unless you're trading in, I don't know, I would say like $30,000 lots or like $40,000 lots or something, you can really just get stuck in a position where it's almost worth to just stay in the position so you don't have to pay the gas, than it is to try and save yourself before the price goes down.
Yeah, and ultimately, this um, uh, as with all things, they always have a second order consequences. The goal was to make it a little easier for the end user. I don't necessarily know if that's the case, because now you have three sliders instead of one. I think the predictability was great. I remember when IEP 1559 was launched, it literally, I remember my transaction getting mined the next block. And I think that's something that is really hard to guarantee, at least statistically. And I remember instead, the usual overpaying strategy to try and get mined, and then still having to wait maybe 20, 30, 45 seconds, something like that. So I think it brought more reliability, but at the same time, it didn't ultimately solve for these high demand, time constricted requests, because you can still kind of sidetrack that by just tipping directly to the miner, which is kind of the other side of the discussion, right? So if you go again on MetaMask, you have the max priority and the max fee. You can look at the max fee as effectively the sum of the base fee that you're gonna pay, which is the cost that is now is intrinsic in the block. It's no longer something that you have a decision over. It's decided by the network, plus the priority fee, which is basically a tip that you're gonna send to the miner in order to incentivize them to mine your transaction. And as far as I understand the priority fee, and I may be wrong, but this acts kind of as a multiplier, where the more you bring this up, the more extra tip you're going to be giving to the miner, which means that your gas cost, your transaction costs will also raise by fairly drastically, because you just end up multiplying your cost by whatever you need to pay. Because again, the gas that you actually end up paying, the transaction cost, is the amount of gas, the units, which you hard cap with the gas limit, and then it's the gas price, which is the price for each unit of gas that you're paying in Gwei. And so anytime you add this multiplicative property to the gas, such as adding this priority fee, you actually end up increasing your cost multiplicatively without even realizing, right? Because you're multiplying these amounts. You're not just adding up, $10. You're multiplying, but $2 per gas, etc.
So I guess, all right. So trying to think about the implications of this for just like an everyday user. So we talked about the gas limit, and that's really something that's just how much data is in this transaction. So it doesn't make sense to change that. The max priority fee and then the max fee. The max priority fee is kind of like the multiplier that you can move up or down to increase the prioritization of your transaction? Or like how would it make sense if you had, say, I guess there's two places where this makes sense, right? If you're trading and you want to pay more to have something done now, or if you're a Prius driver and you're trying to save gas and reduce your costs, and you don't really have any sense of urgency, you would want to kind of bring that down to the minimum. So between these other two knobs that you have, the max fee and the tip, which is the most effective, or are they kind of both doing the same thing?
I believe that the max fee, just like the gas limit, it's gonna be a cap on how much you're willing to spend. So that gives you predictability, and it's used in the math on MetaMask. If you check at the top, you'll see max fee. That's what they use to show you your price. But in terms of effectiveness, you unfortunately have to move both, because the more you raise the priority fee, the more the max fee has to increase correspondingly. At the same time, just like with the gas limit of spending 200k gas on a Uniswap swap and setting it to 1 million, there's not going to be that much of a downside. I believe that the max fee as well should not cause that much of a downside if you sell it to a value that is too high, because ultimately the base fee, which is embedded in the block, plus the priority fee, which is the one you specified, will make it so that it will determine the actual fee that you're going to pay at that time. So increasing the max fee, you should increase it only linearly without you increase the priority fee. But ultimately, increasing it to too much just means that if your transaction doesn't get mined early, it eventually will be mined at a more expensive rate. But it should also not force you to pay that much, because again, it's a maximum amount that you're willing to pay, more so than the exact amount.
Okay, I'm not sure. So if I'm a gas conscious trader and I want to pay, say I have a transaction and I want it to just go, I don't care at all when it goes through. It could go through tonight when I'm sleeping. It could go through tomorrow. It could go through in 48 hours. What is which one of these do I change? Here's what I have been doing, right? Like if I have a super low priority, I'll go look at, I forget what the website is, right? And see what is the cheapest gas. It's usually for me overnight, right? Like say, for me in the evening at 4 a.m, gas goes down to like 52 or 54. And then I would set the max fee to around that, to 52 or 54, put the transaction through and go to bed, and then hope in the morning it's gone through. Is that a ridiculous strategy, or is there a more efficient or cheaper way to do this?
So because of how the EIP 1559 transaction format is, where you're specifying a maximum amount of gas you're willing to pay, or a maximum amount of ETH you're willing to pay, and then you're specifying the tip, then arguably the thing you can do is to reduce the tip to 0 or to a very low number. And then and I believe when it's 0, basically every single individual that tips over you will get priority. So you may literally get stuck forever if there's any block that doesn't have any gas left. But that said, if you set the max fee to a low value, then that guarantees you that your transaction will be mined only when the sum between the base fee, which is the cost for the specific block, and the priority fee, the miner tip, basically needs to go down to that level. So ultimately, checking for demand is a great idea, and it's a great strategy. Most people I know will try and do that over one day. So they don't typically have a week horizon when they're trying to save gas because of opportunity cost. But when it comes to a day by day, it is a pretty good idea for you to run let's say a trade or a swap or an approval or a deposit in a vault or a bulk deposit or a deposit on a lending protocol or something like that overnight, especially if there are no slippage checks. Because if the transaction can't get front run and you're going to get basically the same value, a day of difference doesn't really matter. And again, by lowering your max priority fee and your max fee and the priority fee, you will be able to pay less.
Yeah, I guess like in my mind, when I look at gas and look at how high and low it is, it's on this number of, it's basically like the max fee, right? Like that's what you get shown on these websites. Like I know that, okay, 50 gas is like fairly low, and 150, 200, 300 gas is way high, and I'm going to wait. But I don't, is there a way of checking like what these max priority fees go down to? Because like I don't see that data really displayed for people to see. Like, do I know that, will it ever get down to zero overnight? Is that what's causing the low gas, or is it what is causing that?
So ultimately, the priority fee comes into play only when there's too much demand on a block. At least that's how it was built. You're not supposed to pay the miner tip unless the miner has to choose between other competing transactions. Um, in terms of historical data, I personally use Etherscan's gas tracker, which shows me the currently used, the currently ideal priority and base fee. That's what I typically use. And then you can go on historical Oracle prices, but unfortunately they tend to be condensed into one number. So whenever they get condensed into one number, you want to go back to the max priority fee, the max fee, because the max fee is the sum of the base fee and the priority fee, and ultimately is comparable to the old way of doing the math of having just one number. So if you want to use historical data, which you can find at etherscan.io/gas tracker, you can also find it at ifgas.watch. They show you the average price. For example, 10 European time on a Sunday, we get 50 GUI average, while on a Monday at 6 p.m. European time, I see 300 gas. That's the difference you can see. But again, those will refer to your max fee. So you still have to run your own math, unfortunately, in terms of determining how to move the true option or the priority fee, because those are going to be related just to the max fee.
Zapper also has a 7-day trailing. It's kind of nice. It's like a little graph, but it doesn't show you like a whole lot of details. It's still useful though. You can see that gas is lower than it was or higher than it was in the last couple days, and then it shows you what the current average fee is.
All right, so we've talked about ways that you can check for the historical price of gas to maybe tie, either if it's a transaction that doesn't need to be done right away, there are no slippage checks, you can set it to run overnight. What is there? So like, yeah, and this doesn't work in, for example, if you're doing a Uniswap trade, right? Because if you set a trade during, like if I set a trade during my working hours, then in the middle of the night, the prices are going to be different, probably more than 1% or 0.5% or whatever the slippage is.
Right. There you would have to increase the slippage, yeah.
So is there any way to do low priority swaps like overnight, or is that always not gonna work? I know I've tried to do that, and there's also I think Uniswap has like a 20-minute just a timeout function on any transaction. So even if the price is exactly the same, you're still going to get timed out. Are there any ways to kind of set these up to happen automatically or when you're asleep?
I think you would either have to write code, right, at that point.
I think you can give your side of the story on the math of it and the economics of it. I think ultimately, when it comes to trades have a deadline, and so you basically are in a way in signing a low priority transaction. You're doing two things that are really dangerous, or at least that they can get you wrecked. One of them is that each trade has a deadline, so you are basically betting that your transaction will go through before the deadline. And the fact that the transaction doesn't go through before the deadline doesn't mean you're going to pay zero gas. It just means that your transaction will fail. And when it fails, you get a revert message, but the miner still gets your fee. So ultimately, trying to save pennies on a transaction that may be really important to you can be a bad idea, because if your transaction is going to fail, it's going to fail publicly and you're still going to pay the gas for it. Anytime you sign it, it's going to get executed no matter what. So having that deadline check just means that it's going to go on the revert case. And again, you're going to pay some gas for that revert. So that's one. And the second one is that you're broadcasting your intentions to the world, because the mempool, which is the let's call it, it's basically the same as BitTorrent. It's just the peer-to-peer set of connection and the shared data that is there about transactions that haven't yet mined inside of Ethereum. That's a public place. You can build a bot, or there's tools that allow you to explore the mempool. And that means that the second you sign your transaction and you push it to the mempool, everyone is aware of what you're trying to do. And so if there is an opportunity for you to be front run, if there is an opportunity for you to get wrecked, somebody is definitely running the math to check that. And so the slower your transaction is, the more optionality you're giving to front runners ultimately. So in a way, yeah, there is no such thing as a free lunch. You're either paying more gas to get your transaction mined early, and you can still get front run. I'm not saying that higher gas saves you from front running. It doesn't. But this lower transaction just means that you're giving even more optionality to bots and arbitrageurs, and you're also risking the risk of getting your slippage checks or your deadlines to fail, which means that you're still going to pay that gas. So in a way, what my advice is that if you can bulk an operation, so there are aggregators. I think Comfy is one, Cozy.finance is another. They basically, I think also PyDAO built something where they bulk deposits in their vaults. If you can bulk it, that's typically a better way to save gas. Instead of you paying a little less to run your own single operation, just send your tokens to an aggregator that bulks those operations so that the complex operation is done properly, is done with slippage checks, is done by avoiding front running, is done by a private RPC, it's done in a way that is a lot more likely to succeed. And it's been bulk, it's been run for everybody, for a lot of people. So that way you share that cost instead of paying for it exclusively yourself. So that's my biggest advice for saving gas.
So what are the types of transactions that you can do that for?
An example would be depositing in a set. If you want to deposit on a Badger set, you're going to deposit yourself. That's going to be fairly expensive. While an aggregator allows you to deposit in their aggregator, and then they will do the bulk deposit for you. That's an example. I believe PyDAO does it for certain vaults. I also believe either Lazy or Cozy Finance does it as well. We eventually will have a tool that allows you to do that as well at Badger. And I believe also Untitled.finance does it for their own vaults. So it's absolutely doable. It's based on the permit pattern, which means that you're going to sign a message instead of signing a transaction. Notice on a security level that signing a message is the equivalent to giving your keys away, to at least giving your coins away. So it's not something you want to do lightheartedly. You want to think about what you're doing. But ultimately, through the permit pattern, the operator can actually run the transaction for you and basically save you the gas. You don't pay any gas.
So depositing into a set. What about claiming rewards? Is that something that has to be, I guess that happens every few hours, right? So that has to be done within at least before the next harvest is run. Is that right?
Yeah, because of how the Badger tree is built, where we have cycles, and cycles, I believe, invalidate the old proofs. So that means that you cannot claim with a proof from 2 hours before, after the cycle is run. You basically would have 2-hour windows, which from my experience is, maybe you can save 10% gas, I guess. But would you even risk it? I'm not super sure. That said, if I can drop some alpha, I'm working on the on-chain version of Badger Tree, which is called Badger Rewards. And with Badger Rewards, because you can claim rewards from the previous epoch, which will be from the previous week, you can wait an entire week or even a month or a year and have a transaction that slow. And because the math is already set, you would actually be able to wait that time. So if your opportunity cost allows you to wait, if the math is fully on chain, you can actually get away with insanely cheap operations. So anytime the math is already set, you can always take your time. Anytime the math can change, think about even like a compound, a token that changes over time. You have a deadline. You have a hard deadline on getting that transaction in, and so you have to really weight your possibilities there.
Here's a question just to confirm. A wallet is serial, right? Like, so if I want to do parallel transactions on Ethereum, I have to use multiple wallets. There's no possible way to queue a transaction like that and then send out a higher gas transaction in front of it or something like that?
Yeah, because of how transactions are done on your wallets, they are queued by nonce, which is just a number that increases one each for each transaction. You will be forced to run the lower nonce until you can run the next one. So if you, for example, run a very slow transaction and then right after you sign a very fast transaction, you're gonna have to wait for the slow transaction until the other one can be even processed. So you will need a different wallet every time you want to do this type of fast operations or slow operations.
Then if you are depositing in a lot of things and want to trade at the same time, it makes a lot of sense to separate those concerns, even though it might feel like you're going to spend more gas because you have to transfer the funds back and forth between the two wallets. You're actually saving a lot of gas because you can do cheaper operations on the one wallet and more expensive on the other.
Yeah, ultimately, you probably once it gets to that point, my biggest advice will be to learn a little bit of Python, and you just have to simulate the operations. That's probably the best thing you can do. Would be to take something like Brownie, learn 20 lines of code of Python, and just run through all the operations and see what the gas cost will be, and that will allow you to really do the math and really be proper. But as a general rule, general account management idea, you probably should have a slow account and a fast account in terms of security as well. And your fast account is literally an account where if you lose all the money, it's fine. You literally understand the risk you're taking. It's called a hot wallet or even a burner wallet. And then the slow account is the cold wallet. And on the cold wallet, when you need to do something, you pay the premium for it. You do very little things. The savings on the cold wallet are because you pre-planned everything and you just don't do. Because if you don't sign anything, there's no security risk and there's no gas cost to be paid. And then on the faster wallet, you take a little bit more risk and you try stuff. And then over time, once the risk is reduced, an example would be Yearn. 2 years ago, going on Yearn was a YOLO operation. Using Yearn today is not particularly scary. It's the same code for 2 years. So you could invest your cold wallet assets there, but you definitely wouldn't put them on something too new. Something like the new farm on the new chain. You would again, you save gas by doing less in that case.
All right. Yeah, no, this is good. I hadn't thought to do like a fast and slow wallet. I think that makes a lot of sense. I don't know, do you have any other tips for optimizing gas? I know one thing I've been using more, and I know we at Badger have been using more, is cow swap. And that is something where you don't even need to, you may need to pay gas to approve the tokens, but it's actually taking the fee out of the whatever token you're selling, right? So you don't even need to, you're not paying Ethereum for most trades there.
Yeah, and I have to say, we almost lived in a world where cow swap was going to be the norm. Unfortunately, and it's it's double-sided sword, but unfortunately, EIP 1559 forced the transaction to have a greater than zero base fee. So every transaction on Ethereum needs to pay something. Unfortunately, because we could have lived in a world where you basically flash bots every operation on Earth, and you just pay the miner with whatever asset you're moving by giving them a fee that way. And that's kind of what CowSwap is doing, with the exception that CowSwap is doing it at the application level. And again, they can't do the approve for you. You got to pay for the approve. But once you paid for the approve, you basically went through the operation we showed in the security video with Wasbi. So you still have to be mindful that CowSwap may be hacked or there may be problems with it. So again, you're giving full approval to the router. But once the router has approval, then they use what they call the batch solver to basically take all the requests that they got, try and find coincidence of ones. That's where CowSwap comes, cow, and try to see if they can minimize the amount of swaps that they have to do on chain, because a transfer costs way less than a swap. A swap costs 200,000 gas. A transfer typically costs 21,000, let's say 40,000 gas. So it costs 5 times less at the very least. And so by combining those operations and trying to minimize the differences in wants, they basically reduce the gas cost by an enormous amount. And the biggest reason why, and I really want you to think about this as the listener, but also you guys, is that these systems are built for maximum security, and they're built in such a way that you're gonna pay the same amount to move $1 as you're gonna pay to move $1 trillion. There is no difference in cost for moving a different size, right? So if you really think about that, then that means that if you can aggregate stuff, which is the entire idea of layer 2s, by the way, if you can aggregate things, then the only bottleneck is kind of the base layer and the amount of number of operations you can make. But if you make each operation more precious, if you make it more complex, let's say what Arbitrum does or Optimism does, where their operation is basically timestamping the proofs and the status of the system, then that's how you can actually scale to massive amounts, and you can also save ridiculous amounts of gas. Because again, instead of doing multiple operations on a very precious real estate, you're doing very few, and but those few operations really count. You're making them count a lot more.
Yeah, that's really cool explanation of cow swap. So essentially, it's building an order book, right? Since it's so let me see if I get what you're saying correctly. Since everyone's given up permission to them to be able to transfer their tokens, they don't have to necessarily go and do a swap on Sushi Swap or something like that. They can actually say, "Oh, actually, we found these two users that want the same thing, and we can just swap their tokens."
That's there's one nuance there. The router is programmed to use signatures that are built through their, I believe it's called the Gnosis Balancer Protocol V2. You can go and check it. It's a really, like, Gnosis are one of the best developers in the space by far. Really great tech. But ultimately, you're signing a transaction saying, I want to sell. You're basically signing a sell order. I want to sell my tokens for that amount of return token, and I'm willing to pay that fee at that deadline. And the deadline is still there because, again, anytime there's a swap, there's value to be extracted if you don't have a deadline and a slippage check. So they still enforce a deadline. And once they see that, let's say that's the left side, that's the Ethereum to DAI, for example, and then they find somebody else that is willing to do the opposite trade, DAI to ETH, then they see the balances and they try to match them. And the way they do that, if you want to be super nerdy about it, there are multiple ways, but they actually open source that code of the resolvers. And I believe the resolvers use a simplex method, which is a linear program, a linear optimization technique that allows them to minimize the difference in all the balances that want to be swapped at that time, with the goal of minimizing the amount of gas that has to be paid and the amount of fees. And I believe the excess value that this resolver can get is then sent to them. So they have an economic incentive in making it cheap for the transaction to happen. And I believe they have an economic disincentive in making it too expensive because they end up paying the tab for resolving the batch and resolving all of those transactions. So in a way, while the hosting of these transactions is in a database, so it's most likely not decentralized, or I guess it could be if they started sending these orders on IPFS, which I'm not sure if it's a good idea or not. But ultimately, there is actually a vision for fully decentralized coincidence of wants trading. And once it reaches enough scale, and I believe CowSwap really did a great job in growing and building a great product, it ends up becoming always cheaper. Like it's a snowball where it gets cheaper and cheaper and cheaper and cheaper over time because you're solving for more people wanting to do more swaps. And as such, you have more of that available pool of tokens that can be swapped without using an AMM.
Yeah, CowSwap's great. I've been using it now for a couple months and I love it. And especially you get the moo sound every time your swap goes through.
You get the moose sound, yeah. Amazing.
That's so satisfying, I know. So for anyone who's been listening this long, let's do some alpha, right? CowSwap is releasing a token soon. I think if you own the Gnosis token and lock that, you get more of a supply of CowSwap. I know Badger is on the airdrop list for that because we've been using it a lot. I'm on the airdrop list. Do you think that this value is ultimately going to go down to the CowSwap token? Do you think the Gnosis token is going to accrue any of this? Like, how are you both playing this?
I haven't looked at the tokenomics at all around it. I mean, it could be a governance play like Uniswap where the token doesn't do anything and you buy it and it goes up because CowSwap gets bigger and it's a governance token. I certainly I'm going to get an airdrop because I've been using it, so I'm planning on holding it. But normally for me, once I get the drop and then I start seeing the price move around in my own wallet, that's when I start getting a sense for the market and doing a little bit more research and that sort of thing. So yeah, that's as far as I've gotten.
I also don't have an opinion on the trading. Historically speaking, I think the Gnosis token was one of the like not particularly performant on an economic level or a number level. In terms of team, I think Gnosis may be the best team in the space. Like they built Gnosis Safe, they built the fixed product market maker for decentralized prediction markets, completely open source. They built CowSwap, completely open source. They now basically are going to open source the Gnosis chain, which used to be XDAI. So on an engineering level, they are absolute legends, and they gave an insane amount of value to the space. So I think they like if you look at they say if you stay on the river long enough, you'll see the corpse of your competitors there. I would say Gnosis is the prime candidate to survive long enough. Although I can't speak about the price of the token because it seems like they are a lot better at building stuff than at hyping. So as you know, in crypto is more about hype, but I think it's an amazing team, and so I'm really optimistic about their work. I think they're just awesome. Their work is great.
Do you think in a world where more and more trades are happening on CowSwap and they're extracting the value for their system, this is going to hurt Uniswap and Sushi and their LPs, and because more and more of the share is just going to be sucked out from their liquidity pools?
That's a great question. So I think we're moving towards a scenario, and the issue is like how difficult it is to actually code smart contracts, how scary it is, and the risk that you incur. Okay, because it really is a like you just gotta be really brave in building this new tech because things can really go wrong really heavily, and unfortunately, people's life can be impacted as well. So it is a really scary environment to build on, but the technology that emerges are basically timeless and they're priceless. So, but given that preamble, I think the future is actually just-in-time liquidity through flashbots, which means that you may actually find exchanges that have zero tokens because there is no advantage in showing you what I'm willing to trade for something. There's zero economic advantage, just like using Twitter. There is zero value in using Twitter, broadcasting your opinion, but there is a lot of value in hearing others people's opinion, right? You basically you use Twitter. The only advantage you get in using it is that you're going to get canceled. That's the advantage. But in listening to people on Twitter, you can find trades, you can find business ideas, you can find business opportunities, investment opportunities. You can basically network. You can do a lot of amazing stuff there. And so in the same way on an exchange, if you actually lock your LP, you're basically telling the other side, whoever it is, how to run the trade because there is always a mathematically optimal trade there. While if you move your liquidity and you just in time add liquidity, so you basically always front run to add liquidity, it gives you the advantage. And at the same time, it means that your liquidity can be used in multiple sources. So I would expect that that's what the future is going to look like. We're going to have smarter AMMs. You can go and look at what Balancer is doing, where they're integrating Aave directly into their Balancer pools. That's going to be a prerequisite for AMMs. And then, which means that your assets are not just sitting there doing nothing and they're not locked in one pool. But the reason why we did it is the risk. Again, the risk at this level is insane. It's really difficult to do things right with smart contracts. And so, but ultimately, if we can figure out the tech, you're going to have just-in-time liquidity with tokens that are continuously being rebalanced and reinvested into different pools to maximize their ROI. And so that's a lot closer to the future. So I will argue that neither CowSwap nor Uniswap v3 will be the AMM of the future. There's going to be more iterations and they're going to be ridiculously more complicated and ridiculously more helpful. They're just going to do more things.
All right, my mind is blown. I'm gonna go pull my Uni V3 LP. No, I think that makes a lot of sense. Like there is like from V2 to V3 LP, you saw this like big leap in efficiency, right? But then it's still sitting out there for everyone to see, right? How much liquidity is at any given price, and
yeah, and you have free pools for Aave. Like, why do you have the 1%, the 30 basis points, 50 basis points, and 1% pool on Aave? Why is Aave not staked and at the same time liquid? Like why am I not reinvesting the Aave in Aave while it's in the pool when it's not used? Like all this stuff, it just it just makes it really impractical and just less efficient at the capital level, and it's done because of a risk ultimately and the complexity. Funny enough, on a teaming level, you probably would want to bet on Uniswap coming up with the Uniswap v4. That would be the optimized version, because historically they've been leading at that level. They may be the best on earth in building new AMMs. But at the same time, I think we can see that there's a long road ahead of us in terms of building a great technology that really fulfills its potential. We're so far away the potential. And I think the last thing I want to mention in terms of that is, again, the example of the layer twos, right? So and this is something that Anthony Sassano says in his daily way every day, basically. But I'll tell for people that don't listen to him, it's like the merge is not going to make gas cheaper. The merge is literally not going to help at all for gas. But the thing that is going to help with gas is this idea that I mentioned before of bulking high value operations. Because if you bulk a set of high value operations, you're just paying the little gas for a lot of value. And so if you do that on a layer two, now the entire layer two can be bulked into one transaction on layer one. And that means that you already have achieved 10x to probably 50x. We'll see 50x improvements this year. So if you were supposed to pay $20 for a swap, you're going to pay, what is it, 50 cents? You're going to pay 50 cents by the end of the year. You're paying $2 now. If it was $20 on mainnet, you're going to pay 50 cents by the end of the year when Optimism and Arbitrum put their turbo versions. But imagine if we add an Arbitrum on Arbitrum, or an Optimism on Optimism, or even an Optimism on Arbitrum, so that it's a meta level of timestamping. So it's a meta level of precious operations being bulked together. Then your 50x optimization can actually become a 50 times 50, which I need to Google. What is it? 2,500 times, right? It's ridiculously more efficient. And it's how you actually end up scaling. You scale because the things you do are more impactful. And that's maybe a metaphor for life. You scale because the things you do are more impactful, because we only have so many limited resources. Like we all have 24 hours. So the way you scale is by doing things that are more meaningful. And the way an Ethereum layer 2 or layer 3 scales is by doing more meaningful operations with the same limited gas that they have.
I think that makes a lot of sense. I remember there was a time, I don't know if it was over the summer when NFTs were going crazy, but there was a period where gas was just crazy high all the time. And then it took a big dive, 20 or 30 or 40 points kind of on average each day. And people were wondering what was happening. And it was one of these NFT minting contracts that everyone used. I don't know if it was like an Open Zeppelin or just one of these common NFT contracts. Someone made a gas optimization in that. And because NFTs were taking up, or still are taking up so much of ETH transactions, that just that one optimization, that one contract kind of rippled out through the whole system. So it's amazing how these like one-time optimizations can then just get multiplied out through everyone.
Absolutely. In a way, we are really going through the Cambrian explosion of evolution of smart contracts, where the strongest does survive. On a human level, on an economic level, there are opportunities for everybody taking part. But ultimately, I think we're trying to really build the best tech there is, like as in unquestionably best, as in compound. There's even a bounty if you're interested. You can make you can get $100,000 bounty if you can save one storage right from Compound's contract. And that's kind of the future we're moving towards, where every technology is highly optimized, and it's the best because it's literally the best that all the people on Earth were able to come up with. And because it does provide for the people using it. So it in solving gas and having gas optimized contracts, you're really making Ethereum more accessible to other people because of the second level consequences of having cheaper gas, less gas used, which means more transactions, et cetera, et cetera.
Awesome. Well, we have been, I think we originally scheduled this for a quick half an hour chat on Gassss, and we've been going for over an hour here. So I want to be respectful of your time. But this has been awesome. I think we've extracted a lot of ways that people can either save on gas or tools to batch their contract or batch their transactions and do it at the right time when gas is low. So Alex, Hal, thanks so much. Is there any final thoughts you have or last tips you want to leave with people that maybe we didn't cover?
No, I think we're good. Yeah, go use cow swap.
Yeah, go use Gassss. And yeah, I think the last tip is really the operation you don't run is the operation where you actually save gas. So just be really mindful, do the math, really think about what you're doing. Some people learn by getting burned. I'm one of those people where I need to have a stake in the game to even focus. So I understand that. But the reality is most of the times you're doing very logical operations when using Ethereum. So just think them through before doing them. You know, it's 3D chess for a reason. So go play 3D chess before running your your operations, and you're gonna save gas by default.
So I'll drop one little thing of alpha, which is if prices are moving down really quickly and gas spikes, then there tends to be a bit of downward momentum that follows that. And then if prices are moving up really quickly and gas spikes, like what happened recently when Bitcoin turned around, then there tends to be some upward momentum that follows.
Because those are the liquidation bots kicking into gear.
Yeah, I view it as like you have to think of, a bunch of people ran out the door, and it's a really small door that you have to run through, right? The blocks, and then now they're all trying to run back in through the door, and so yeah, you kind of get an idea of where everybody wants to go.
Yeah, I like that because you're saying that gas is a volatility index, and I think that's the case. I mean, it's been smoothed out by 1559, but it really is a volatility index because ultimately it shows that there's a lot of more demand, and so if you can interpret why there's demand, you ultimately have more opportunities for a trade, and so it is you probably as a trader want to have a gas. Checker. You want to check the gas very often.
So there you have it. A GUI saved is a GUI earned. So guys, thanks for taking the time today, and look forward to next one.
Yeah, thank you.
Thank you for having me. Have an amazing one.